Students, the next is the initial rate method, which is used to determine the order of the reaction, right? So in this method, it is preferred because here we can take more than one reactant. So in this method, we are just going to find out first the initial rate of the reaction, right? And then with respect to one of the reactant, and then keeping the one of the reactant constant, we will determine the rate of the reaction with the change in the other reactant term. So at a time we are not going to find out together. We will just find out by keep the rate of the reaction in term of the one of the reactant and keeping the other reactant constant. So just see here that we have I have just made to just explain this method. I have taken this example. Right here the reaction is between nitrogen dioxide and fluorine, N2NO2 plus F2 gives 2NO2F. Right, this is the reaction, and this is the table of the, we can say, data which we have obtained. Now here, for first we have got the initial concentration. Now this the space was not sufficient, so I expressed it here, that this is expressing here the initial concentration, and that will be in term of mole per liter, right? And same here also. There is also initial concentration of fluorine in moles per liter, and the two stars, that is the initial rate here, is expressed in the moles per liter per minute. Right? So we have got obtained this table. So when the initial concentration is 0.20 of the NO2, fluorine is 0.05. That time the initial rate which is obtained is 6 into 10 to the power minus 3 mole per liter per minute. In the same way, this is for the second data obtained. This is the third data. Right? Now we have to use this data and obtain the order of the derive the order of the reaction and express the rate law. So students, here first of all we will just write the rate law, right? So we will just take, let the rate law be, so I equals to, so we don't know that what will be A and what is B, right? That is, here this is the stoichiometric coefficient, but we have to find out A and B, which will be derived from the experiment. Right. So now we are going to express the rate of the reaction in term of this rate law. Right. So we will begin with the first one. So R equals to, what is R? It is 6.0 into 10 raised to power minus 3 equals to NO2. It is 0.20. This is A here. This is 0.05. This is B. This is the student first, we can say, the first equation, right? In the same way, you can find out for the second and you can find out for the third. So students, here we will write down now the second equation. It will be 1.2 into 10 raised to power minus 2 equals to 0.40A, then 0.05, it is B. Students, you have to write down these equations very carefully, because if any mistake will be there, so we will get the wrong answer. So now we will write down the third equation. It is 4.8 into 10 raised to power minus 2 equals to 0.80 A, and this is 0.10 B. This is the third equation. Students, we have obtained the three equations here. Now what we will do, so I am going to rub this side here. I am going to rub the table. Hope so you have noted down, and otherwise you can note it by seeing the video also. So I am just rubbing this part here, right? This much part I am rubbing here now. Okay, so students, what is there, that we are going to now, just to find out A and B, we will just compare the two equations. Now we can take any two equations. in such a way so that one of the this, you can say, the raised to the power part, right, A or B gets cancelled out. So you can see here that this person 2, when we just compare these two, right, or divide this 2, we'll get this part cancelled out, right? So we'll just write down here, dividing equation 2 by equation 1. So how it will be written? It will be written 1.2 into 10 raised to power minus 2 divided by 6 into 10 raised to power minus 3 equals to, it's 0.40 A upon 0.20 A. This is 0.05 B. Here also we'll get 0.05 B. So you can see that this part is going to cancel out. Right. Now remaining part we can write down as 2 into, here you will see it will come 2 raised to power A. Right. So here it will be, here also it will be coming 2. So 2 to 2 cancel. We are getting A equals to 1. Right. So we obtain the value of A here. Now similarly we can obtain the value of B. Right. So for that we have to divide. Right. We just see the values here. So now you know the value of A. You can just put it here and you can just get the value of B. So here we can write down, dividing equation 3 by equation 2. So what we will get? We get 4.8 into 10 raised to power minus 2 upon 1.2 into 10 raised to power minus 2 equals to 0.80 A, 0.10, this is B. Here it is 0.40 A, this is 0.05 B. So here you will get 4 students. So here it is coming 1 raised to power 1. So this is also getting 2, and this is how much we are getting here. This we will get as 2 raised to power B. Right, students? So then we can just get it here. It will become 2 equals to 2 raised to power B. And what will the value of B? It will be, therefore, B equals to 1. So students, we are obtaining A, B is also 1. That means that the order of the reaction with respect to fluorine. Now I am repeating here, the order of the reaction with respect to fluorine is 1, and the order of the reaction with respect to NO2 is also A equals to 1, so it will be 1. So we will just now write down the value of order of the reaction first, right? Because the first part of the question was to determine the order. So order will be A plus B, right? That means it is 1 plus 1, that is equal to 2. So order of reaction, complete reaction, overall reaction will be 2. And if it is asked to find out the order of the reaction with respect to NO2, it will be 1. And with respect to fluorine, it will be also 1, because we are obtaining A equals to 1 and B equals to 1. Now what is going to be the rate law? So the rate law you can easily obtain from here. It will be R equals to, we will just put the value of A and B. So A is 1 and B is 1. So student, this is the rate law for the given equation, and you have obtained the order of the reaction also. So student, this is, we can say, experimentally, when we say that experimentally it was coming raised to the power 1 and 1, right? Whereas if it was theoretical one, or the from the balanced chemical equation, that time it will be NO2 will be raised to the power 2, right? So generally we use the initial rate method where we have got more than one reactant to obtain the order of the reaction.